Dear student, today we are going to start a new chapter, that is square and a square root. So let's discuss what is square and what is square in these chapters. So student, you have already learned about the word square in your previous class. So today we are going to discuss about this square. So let's see the introduction. What the introduction says. See, what is the square of the number you will define here. You have already studied about the square of a number, which is a number obtained by multiplying the original number by itself. That means that the number by multiplying the original number by itself. The original is, for example, 2 into 2. Square of 2 into 2 square of 2 into 2 is 4. 3 into 3 is 9. 4 into 4 is 16. So we said that 4 is the square of 2. If you multiply 2 times, then the number will be square of 2. That is, answer is 4 will be the square of 2. If you multiply 2 times, then your answer you will get the 9. 9 is the square of 3. So on. In 4 also you will get 16. And 1, 4, 9, 6 are known as square numbers. So any numbers, that means if you say 5 into 5, 25 is the square of 5. If you say 11 into 11, 1 to 1 is the square of 11. You have to say, because if you multiply here, number obtained by multiplying the original number by itself is called a square. That means that square is the multiplying the numbers 2 times. Means 2. If you multiply again by 2, then your answer will get 4. That will be the square of the 2. So that is we known as the square numbers. In other words, also we can say that if a whole number is multiplied by itself, the product is called a square of that numbers. Means any whole number, if you multiply by itself again, suppose if you take 9 is a whole number. If you multiply again that 9 by number itself, then the product we call it, that is a square of that numbers. Okay, same thing. So in this chapter we are going to learn about the perfect square, property of square root, and also the method of finding the square root. See, in these chapters we are going to learn about the perfect square, properties of square. What are the properties of a square? What are the perfect square root? What is the square root? How to find the method of square root for finding the square. There are various methods of finding the square root. So we will learn in these chapters one by one. So next we are going to start about the first one is we are going to start perfect square. What is perfect square? We have to see now. Perfect square. A natural number m is said to be perfect square if it is a square of another natural number n. That is, n square is equal to m, where m and n are the natural number. See, the square of 20 natural number. First one, these are 2. 2 is a perfect square. 3 is perfect square. Because 3 you will get 9. So in this way, so we can say that m is a natural number when m is said to be perfect square if it is a square of another natural number, that is n. Okay, n, that is n square equal to m, where n and m are the natural number. Here 2 into 2, 4 is a perfect square of 2, and 4 is also the square of 2. And we can say that again, 4 is a perfect square. If 4 is a square of 2, then we can say that 4 is a perfect square. Understand? So in this way we can here the square of first 20 natural. There are 20 naturals. So we have uncountables. Okay, we have uncountable squares of numbers of natural number. We have only 20 numbers here from 1 to 20. So it is better to memorize this type squares of natural numbers, so that it will be better for the to easy your calculation also. So this is a perfect square. When the two numbers are in the square, answer is 4. It means that 4 is the square of 2. So we will say that 4 is a perfect square. Understand? And again here 400 is a square of 20. Then we will say that 400 is a perfect square. Understand? So this is a about the perfect square. So the properties of square. Now we will discuss this, very important. So please be very. This is very important. So we will learn all the properties of square. Properties of square in this properties, and then there will be the calculation. There will be an important calculation according to this properties of square. We can calculate the problem of the squares. Problem of the this square. So first one, property of square. What it says, let's see. What is the property of square says? If a number n in 2, 3, 7 or 8, it is not a perfect square. Suppose if a number n with 2, 3, 7 or 8, then that type of number is not a perfect square. Understand? The number ending with 2, 3, 7 or 8. That means, for example, 52, 63, 87, 98, they are not be a perfect square. And all the natural number ending with 0, 1, 2, 3, 4, 5, 5, 6, 7, 8 or 9, this digit occur in the unit place. See, 0, 1, 4, 9, these are the all the natural number ending with 0, 1, 2, 3, 4, 5, 6, 7 up to 9. This digit occur in their unit place. See, the square of its numbers: 0, 0, 1, 1 is 1, 2, 2 is 4, 3, 3 is 9, 4, 4 is 6, 5, 5, 25, 6, 6, 7, 7, 49, 8, 8, 64, 9, 9, 81. We can see that a perfect square must be n with 0, 1, 4, 5, 6 or 9. So if when you are going to say a number is a perfect square, at the time you will have to recognize these ending numbers. If 0 or 1 or 5, 4 or 5 or 6 or 9 in the unit place, then you will say that that number is a perfect square. So if the number end with 2, 3, 7 or 8, it cannot be a perfect square. If a number ending with 2, 3, 7 or 8, it cannot be a perfect square. Then we can say that 212. 212 is a perfect square because it ends with 1. Okay. So let's continue next property again. Here is another property. So we have to before we continue the next property, we have to understand that 2, 3 number ending with 2, 3, 7 or 8, it cannot be a perfect square. And a number with 0, 1, 4, 5, 6 or 9, these ending numbers, if this number are in unit place, we can say that they are the perfect square numbers. Understand? The next, if a number, next property number 2, if a number n in in odd numbers of 0, it is not a perfect square. And another point, if the unit place, in the unit place, if the 0 is in the odd number, if the n with the odd number, then that type of number is not a perfect square. See, 1, 1, 0, 1, 1. We have only 1 0 in the unit place. So this type of number is not perfect square because it says that number ends in the odd numbers of 0. If there is odd numbers of 0, see, only 1 0 is there. Here again, 1, 2, 3. There are 3 0. 3 zeros are odd numbers. So they are not perfect square. So natural number ending in 0 are 10, 20, 30, etc. This square of this are 100, 400, 900. Square of the natural number ending in 2s, that is 100, 200, 300, etc. will be the 10,000, 40,000, 90,000, etc. So the perfect square must be 2 zeros, 4 zeros, 6 zeros, 8 zeros, like this. If the zeros are in the even form, then we can say that that number is a perfect square. That means that 100 zeros are in the evens, ending 2 zeros are there. Here how many? 4 zeros. Next 6 zeros will be there. So this type of ending with the zeros, 2 zeros, 4 zeros, or 6 zeros, etc., they are all perfect square. And if the number end with the odd numbers of 0, that is 1, 3, 30, 10, 50, 70, they are not a perfect square. If the number end with 2 zeros, 4 zeros, 6 zeros, 8 zeros, they are a must be a perfect square. Okay, we have learned two things, two properties, that is, if the number end with 2, 3, 7, or 8, it cannot be a perfect square. If the number end with 0, 1, 4, 5, 6, 9, they must be a perfect square. And again, numbers of zeros. If numbers of zeros are odd in the ending, then they are not a perfect square. If the numbers are endings with 2 zeros, 4 zeros, and 6 zeros, that is in even form, then they will be that number will be a perfect square. Understand? So we'll continue the next part, next property, that is property number 3. Square of odd numbers are odd. See, if you one is a odd. If you square, if you multiply 1 into 1, your answer will become odd. And again, if you multiply odd, 3 is an odd number. If you multiply 3 2 times, then answer will be odd. If you multiply 5 2 times, your answer will be 25. That 5 is odd. 7 also odd. So it says that the square of the odd numbers are odd. So all the odd number ending with 1, 3, 7, or 9. 1, 3, 5, 7, or 9. So the square will be end with 1, 9, 5, 9. That is, or 1. That is 1, 5, 9. So the odd number 1, 3, 5, 1, 3, 5, 9 is 7, 9. Their square will be, if the ending with 1, 3, 5, 7, 9, their square will be 1, 9, 5, 9, 1. So that is 1, 5, 9. So if the number, if the odd numbers 1, 3, 5, 9, 1, 3, 5, 7, 9 in the ending in the unit place, then it should be 1, 1, 5, or 9 will be in the 1 place. Understand? So the square of the odd number are the odd number. So if any odd number, a square of any odd number, then in the 1 place it will be 1 or 5 or 9 will be in the unit place. Understand? Now the point number 3, what it says, we'll look at the square of even number are even. If you multiply the square of the even number, your answer will be always even. See, 2 times of 2 is 4, 4 times of 4 is 16, 10 times of 2 is 100, 12 times of 2 is 12 times of square is 12 times of 2 is 114, 14 2 times is 16196. So whenever you multiply the even number 2 times, means square of even number, your answer will be always even number. That means the unit place will be always in the even numbers. So all even numbers end in 0, 2, 4, 6, or 8. So the square will be 0, 0, 4, 6, 6, 4. That is 0, 0, 4, 6. So whenever the square of the even numbers, then if you calculate square of even number, the ending a unit place, in the unit place there will be 0, 0, or 4 or 6 will be the numbers in the end in the unit place. So we have to be very understand about these 2 points. If the square of the odd numbers are always odd, so whenever the square of the odd number has been calculated in the unit place, there will be 1, 5, or 9 will be in the unit place. And again, if the square of the even numbers are always even number, so when we calculate the square of the even numbers in the unit place, it will be surely 0, 0, 4, or 6 will be in the unit place. Okay, the next is property number 5. See, in the property number, the square of the necessary number can be expressed as sum of their consecutive odd numbers. See, square of the necessary number, that is 2. 2 is a necessary number. The square of the necessary number means that is 4. Can be expressed as a sum of the consecutive odd number. See, square of the necessary number is 2. Then square of the square of the necessary number, that is 2 square is equal to 4. So this can be again expressed in the form of sum of consecutive odd number, that is 1 plus 3. Consecutive odd number, that is 1 plus 3. Here in the 3 also 9, you have to put 1 plus 3 plus 5. It should be consecutive, okay? One other and one another after one after 1 3 5 in the sequence orders, not 1 5 7 something like that. So 4, how many odd numbers will be there? 16. There will be 4 odd numbers. Sum of the consecutive odd numbers are here. So the square of natural number can also express in the sum of the consecutive odd numbers. So here, square of 2 is a sum of first two odd number. Yes, square root 2 is the sum of the first two odd number. First two odd numbers are 1 and 3. Okay, square root of 3 is the sum of the first 3 odd numbers. Then square of the 4 is sum of the first 4 odd numbers. And then what about 5? First 5 odd numbers. What about 6? First 6 odd numbers. What about 7? First 7 odd numbers. So on. Understand? So we can say in the general for the natural number, n square is equal to this one, natural number square is equal to sum of the first n odd numbers. First n odd numbers of odd numbers is first 1, and number of odd numbers 1 2 3 4 5 6 7 8. Okay, according to the numbers we can count it. So in the properties number 5, we learned that the square of the natural number can be expressed as a sum of the consecutive odd number. That is 7 square. 7 square is 49. So if you put in the sum of the consecutive odd number, then we have to put how many odd numbers is there? 7 past 7 odd numbers. Sum of the first 7 odd numbers, there is 1 3 5 7 9 11 13. If it is 8 square, then it should be 64. Then 1 3 1 sum of 1 3 5 7 9 11 13 and 15. If it is 9, it comes 81. Then 81, the sum of the odd numbers will be 8 times. Okay, 1 sum of 1 3 5 7 9 11 13 15 and 17, and so on. So the formula is n square is equal to sum of the first n odd numbers. This is a property number 5. Let's again see property number 6. Next is property number 6. The difference between the square of two consecutive natural numbers is equal to the sum of the two numbers. The difference between the square of two consecutive natural numbers. Difference between two square of natural consecutive 2 and 1, 6 and 5, 3 or 4, 4 or 5. You can write any two consecutive square of the natural number. Okay. Here comes 4 square is 2 square is 4, and 1 minus 1 square is 1. The answer comes 2, equal to sum of the two numbers. Sum of the two numbers is these two numbers. Again, it will be equal with these two numbers. Okay. For example, let's see one example. Here also example is there. Now let's calculate one example. 4 square minus 3 square. What is the answer? 4 square minus 3 answer is 4 is 16, 9. What is the answer? 16 minus 9 is how much? 16 minus 9 is 7. Now, equal to sum of the two numbers. You add these two numbers again. 7, 4 plus 7, 4 plus 3 is equal to 7. You take the square difference of these two square. It should be a consecutive numbers, and then this again it equal to the sum of the given two numbers, that is 4 and 3 again. So in this way, here is the example also given. So 6 7, it should be a consecutive natural number. It should be a consecutive natural, and there should be a consecutive natural number. Okay, two consecutive natural numbers should be there. So we can here what we have done, that example is consecutive of 3 and 4. Here is 5 6. Here is 8 9. So likewise we can calculate all the difference between the square of two consecutive natural number is equal to the sum of the two numbers. It can be asked in the exam also. In this statement we can ask, and you can give the example of this. And the next question is property number 7. Here in the property number 7, Let's see. The square of negative integers is always positive. This is correct, because if there is two squares there, the negative signs will become positive surely. Negative negative, it should be negative into negative multiplied by negative into negative, it should be positive. So whenever any square of the negative integers is always a positive integer. It's very simple. So the next is properties number 8. This is very important. Let's see this property. Now in this property, the square of an odd number can be expressed as a sum of two consecutive natural numbers. See, square of an odd number. Square of odd number is 3 is the odd number. Square of the odd number is 9, and can be expressed as a sum of the consecutive odd number. So there will be a two consecutive odd numbers. Okay, 5, 25, 12 and 13, 9, 81, 41, and the 40 and 41. How will you get this? How will you get this number? By using in the general for an odd number a. This is the formula to get these numbers. These numbers. Okay, this is a formula. A square means the odd square. Okay, and this one will be the a square minus 1 divided by 2 is one natural number, and this one is another natural number. If you add these two natural number, you will get the same region of a square. Okay, this question is in your textbook page number. Try this page number 95. So we can use one example here by using this formula. Okay, let's see. Try this page number 95. Question number 1. Question number 1 is, here comes, express following as a sum of two consecutive integers. How will you calculate these numbers? Let's see. 21 square. You have to find out two consecutive numbers. How will you find out? You have to apply this formula. That is, a square is equal to a square minus 1 by 2 plus a square plus 1 by 2. You have to apply this formula. These are the two consecutive numbers. Okay, let's see. A square is equal to what? 21 square. What is the result of 20? It's okay. And yeah, a is equal to what? A is equal to 21. A square means what? A square means a square minus 1, 2 plus 2 consecutive divided by 2. What is a square? 21 square. 21 square is how much? You calculate here. 21 square, 2, 2, 1, 144. That's the reason is 144. So a square is 21 square minus 1 divided by 2 plus 21 square plus 1 divided by 2. So a square is 144. Then 1444 minus by 1 by 2 plus 144 plus 1 by divide by 2. 144. You have to find out. You have to calculate. We are finding the two consecutive number. Okay, here comes 1144 is, and then your answer will come. What? Sorry, this is wrong. 4 4. It should be 4. 4 4. Here will be 1. Sorry. 4 4 4 4 1. It should be 4 4 1. It should be 4 4 1. It should be 4 4 1. Then here comes 4 4 0 by 2. Okay, plus 4 4 2 by 2. Now we are finding two consecutive numbers. There is 2 2 0 plus, and another one is 2 2 1. These are the two consecutive numbers that makes equal with the square of the odd numbers. Understand? In this way, we have to find out the problem, or we have to find out this sum of the two consecutive odd numbers. Understand? This is the uh, problem that we have to solve in this way. In this calculation, you have to apply this formula, and then you can solve the try this page number 95, question number 1. Understand? Next, that one is property number 8. I'm reminding again, the square of an odd number can be expressed as the sum of two consecutive natural numbers. That one we have already calculated by using this formula from the page number 98 Ncert. Try this question. Okay, I have given only by using this I have solved question Roman number 1 question. Okay, you can try at your home by using this uh, formula. Okay. Next is number 9. Property number 9. What it says, let's say the square of the product of two numbers is equal to the product of the square of the two numbers. That is, the square of the two numbers means if you take the square of 2 and 3, your answer will be what? 6. 6 square is equal to 36. That means that the square of two numbers, the product of two numbers, that is 2 into 3, is equal to the product of the square of the two number. The product, this is a product and this is a square. Understand? That means that now let's see the square of two number, the square of the product of two number, this is a square of the product of two number is 36. Okay, equal to the product of the square of two number. If you calculate separately 2 square plus 3 square, that also the answer will be same. That means that the square of the product of two number is equal to the product of the square of the two number. That means a into b bracket square bracket a into b bracket close square is equal to a square plus b square. The answer will be same. If this calculation, if this in the between this 2 into 3, first we can calculate inside the bracket, it comes what? 6 square, then answer is 36. And again, if we calculate separately 2 square into 3 square, that also the answer is 36. The answer is same. So in the general, we can write that bracket a into b bracket close square is equal to a square plus into b square. We can say in this way also. Then the last property, that is property number 10. The square of the ratio of two numbers, that is rational number, is equal to the ratio of their square. Means that the square of the ratio of two numbers, 1 by 3 is holding square, is equal to 1 by 3 into 1 by 3 is equal to 1 by 9. Here also the problem is same. Here is an example. It means that the square of the ratio of two numbers, that is rational number, is equal to the ratio of their square, that is 1 by 3 square is equal to 1 square is equal to divided by 3 square. So in general form we can write here a square by a by b square is equal to a square by b square. B should not equal to 0. Okay, these are the 10 properties of square root, that of not square root, of a square we have to be understand. So I'm reminding again this all the properties once again, and then we will go through the Ncert textbook. Try this few properties. According to these properties we will calculate. So first property of the square, the first one is if a number n in 2, 3, 5 or 8, if a number n in 2, 3, 7 or 8, if the number n with this number, it should be not perfect square. If the number n with 0, 1, 4, 5, 6, 9, then that number will be a perfect square. Then number 2, if a number n in odd numbers of 0, it is not a perfect square. That means natural number ending in 0 like 10, 20, these are not a perfect square. If the ending with 2 zeros, 4 zeros, 6 zeros, 8 zeros in the even numbers of 0 in the ending, then that type of the numbers will be a perfect square. Square of the odd numbers are odd. If the square of the odd numbers, the answer will be always odd. So the answer will be always ending with 1, 5 and a 9. The square of the even number are even. So if you take the square of the even number, the answer will be even number, but in the ending the digit will be 0, 0, 4 or 6 will be in the unit place. So again, Roman number 5. The square of the natural number can be expressed as sum of the consecutive odd number. If you take the square of the natural number, that is 2, 4. So the consecutive, the sum of the consecutive equal to the sum of the consecutive odd numbers. Okay, here comes n square is equal to sum of the first n odd numbers. Is a rules of to calculate this consecutive odd numbers. Number 6. The difference between the square of two consecutive natural numbers is equal to the sum of the two numbers. Then another one is, the next one is, square of the negative integers is always positive. That is, square is the, if you have the square of the negative integers, then your answer will be always positive. And the next, Roman of 8, that we have done already. Here, the square of the odd number can be expressed as sum of the two consecutive natural numbers. That we have done already. We have done the, try this example also. So number 9, the square of the product of two numbers is equal to the product of the square of the two numbers. That is, if you multiply these two, the answer is 36. And if you multiply separately also, the answer is 36. It means that in the general we can write that a into b bracket square is equal to a square plus b square. So in the number 10, the square of the ratio of the two numbers is equal to the ratio of their square. So the form in the general we can write that a by b square is equal to a square by b square, where b should not equal to 0. These are the 10 properties of the square that we have to be learned. So according to this property, we are going to solve the we will solve a few try this Ncert textbook question. Okay, let's take one example. Try this page number 92, question number 1, Romano 1, 727. In the question, the square of which of the following numbers would be the odd numbers and or even numbers, and why? Let's check here whether this number is a square of this number will be odd number or even number. Okay, since 727 is a odd number, its square also is also an odd number. Understand? Here is a odd number, so if we take the square of this 7 to will be the odd number. And let's see one example again, 158. Here is a 8. Since 158 is an even number, so the square also will be what? An even number, because you multiply 151 in 2 times, then 8 is how much? 64. Then in the one place it should be 4, so 4 is an even number. Here comes in if you multiply 7 to 7 2 times in the first place, in the unit place, what will be the answer? 7 7 are 49. 9 is a odd number, so we can easily find out by using that properties. Okay, and the question number 2, let's try the question number 2 also. Try this question number 2. This is page number 92. Try this. Okay, question number 2. What the question say? What will be the numbers of 0 in the square of the following numbers? See, question number 1, 60. How many zeros are there? Only 1 zeros. If you take the square of this 1 0, how many 0 will be there? There will be 2 zeros. Okay, here comes 60. Numbers of 0 is how much? 0 is 1 only. So if you take the square of 60, then the answer will have 2 zeros. It will come 2 zeros. Okay, so the next one is 400. It will come how many? 4 zeros. Understand? So the next question we will have, try this page number 94. The next question is, try this page number 94, question number 1. How many natural numbers lies between 9 square and the 10 square? Now we are going to find out how many natural number lies between 9 square and the 10 square. We have to find out. So to find this, there is one properties we have not learned. So let's recall that properties. There are 2n non-perfect perfect square. Okay, 2n non-perfect square numbers between square of number n and n plus 1. This is another properties. Okay, there are 2n non-perfect square between what, n and the n plus 1. Now we are going to consider this 9 square will be n, and this one will be n plus 1. Understand? Here comes solution. Let's see the solution. N equal to what? The first number will be n, 9. So according to this question, n is what? 9. N plus 1 is 9 plus 1 is equal to 10. Understand? Then you take the natural number between we are going to take the natural numbers lies between 9 square and the how many natural numbers are there between 9 square and the 10 square. Then again, natural number between 9 square and the 10 square is how much? 2n. That is 2n perfect non-perfect square are there. So therefore natural numbers between 9 square and 10 square are n into 2 into n. That means that 2 into 9, that is 18. The answer is 18. So if you count here, see 9 square is how much? 81. 10 square is how much? 100. Here if you count here also, there are 18 natural number will be there. So when the numbers are bigger, when the number are large, something like uh, 2000, in the question number 2 also there is also another examples. There is also another example, another question. How many non-square numbers lies between the following pairs of numbers? That is 90 square and 91 square. When the number are large, at that time we need to find out according to these properties. Understand? We are going to find out according to these properties. So let's see one example from question number 2 again. Let's take one example from question number 2 again. Here is a question number 2. Let's take this one is page number again. This one is page number, same page number 94. Okay, 94, question number 2 question. We are continuing another example again by using these properties. Understand? Let's see Roman number 1, Roman number 111, Roman number 3. That is 1000 square and 1001 square. We have to find out how many non-square numbers lies between these two. Then it will be very big problem to multiply this 2 times and this 2 times and to find out the numbers. So we are going to apply these numbers, this formula, these properties again. So here n equal to, which one is the n? 1000 is the n. Which one is n plus 1? N plus 1 is 1, 0, 0. 1 is n plus 1 according to this number. Okay, so according to this n and the n plus 1, there are 2n twice n non-perfect square numbers are there between n and the n plus 1. So natural numbers not natural number, here comes non-square numbers between 1000 square and 1001 square are 2n, twice n. Then n is how much? 1000. Then how many numbers, how many n, how many non-square number will be there? There will be 2000 non-square number will between 1000 square and the 1001 square. Did you get my point? According to these properties, see, here is a point. There are 2n non perfect square between square number between square of a number n and n plus 1. This is a formula. In between n and the n plus 1, there is twice n numbers of non-perfect square. Did you get my point? Okay, student, this is a part 1 for the chapter number 6. So in the next part we will continue again few examples, and if you try this question we will discuss according to the properties. So for today we will wind up here. Thank you.